What is up guys, this is Luke Hill for Kit Guru, and here we have two of the ASUS ROG Strix B550 offerings. So brand new, hot off the press, B550. We've got the B550-E gaming and the B550-F gaming Wi-Fi. So these are two of ASUS's more premium B550 offerings, which is unsurprising given the ROG Strix branding. They've both got high-end power delivery solutions, the typical ROG Strix design, and then some other cool features such as high-speed networking capability. Let's take a closer look. If we start off by looking at both motherboards, you can see that we get the typical ASUS ROG Strix styling. So you've got dark black, dark greys, you get touches of lighter colours here and there, and then you've got sprinkles of red. RGB is present and subtle. You get a bit on the rear I/O cover and a bit on the chipset, and importantly both of them have a 6-layer PCB. So looking over at the 24-pin area, you can see that we get the usual set of connections. So obviously you've got the 24-pin connector, you've got an internal 5 gigabits per second USB 3 header, and then you've got some debug LEDs which light up during post, and these are great for seeing any troubleshooting issues. Importantly, the B550-E gaming actually includes a USB Type-C internal header for 10 gigabits per second connectivity on the front of your case, but the B550-F gaming Wi-Fi does not. So that's a big tick for the E, a bit disappointing from the F. Notably, neither of the boards have onboard power or reset or clear CMOS buttons, which in the case of the E is actually a bit disappointing given that it's higher end and it will attract some tinkerer overclocker audiences. You do not get voltage monitoring points on board for either of these motherboards, but that's probably fine given the target audience of B550. If we move around to the top edge, you can see that both motherboards actually have 8 plus 4-pin power delivery connectors. You've got a couple of fan headers along the top edge on the F, but that's actually 3 fan headers on the top edge for the E. And the E goes one step further, so both have 4-pin RGB headers on the top edge, but the E also adds in a 3-pin addressable header in this region. Moving along to the SATA area, we can see that both boards have 6 SATA ports. These run from the B550 chipset. If we focus on M.2 connectivity, we can see that both boards actually support dual M.2 slots with drives up to 110mm in length supported. You get 2 aluminium heat sinks with thermal pads to cool the M.2 SSDs, and the positioning is very good. So you get one above the PCIe graphics card connector, if you like, close to the CPU, so you get any incidental airflow from the CPU fan and it's not being vented on by a graphics card. And then the other one is down the bottom near the chipset, so short trace lengths, and it's also out of the way of the heat being dumped directly from the graphics card. Smart positioning overall. The top slot on each of the boards is a Gen 4 x 4 link, or up to Gen 4 x 4, run directly from the Ryzen 3000 CPU. This is good to see because you can support high-speed drives without any of the bandwidth headaches that will be introduced when you're looking at the CPU to chipset Gen 3 x 4 link. If we now focus on the second M.2 slot, that's actually a PCIe Gen 3 capable X4 connection from the B550 chipset. So it doesn't support Gen 4 SSDs, and because it connects to the chipset, you will run into some bandwidth headaches if you're also putting a lot of data through the SATA ports because you've got a Gen 3 x 4 link between the B550 chipset and the CPU. Also, it shares its bandwidth in each of the cases with 2 of the SATA ports, so if you install a drive in those 2 SATA ports, or even one of them, it will drop to PCIe Gen 3 x 2 connection. If we focus on the PCIe slots, in both cases the top port is a Gen 4 x 16 slot direct from the CPU and is steel reinforced for extra bit of rigidity when you're putting a graphics card in there. Focusing now specifically on the B550-E gaming, we can see that it has a second slot which is also steel reinforced, and this indicates that it's Gen 4 but by 8. So that will steal 8 lanes from the slot above it, so you can either run these 2 slots on the B550-E gaming as X16, X0 from the CPU with Gen 4 lanes, or X8, X8 from the CPU with Gen 4 lanes. Because you can do X8, X8, it actually does support proper crossfire and SLI if you're really into that. Importantly, you could actually run very similar to what Gigabyte does with its competing B550 Aorus Master, but in a different implementation. You could, if you wanted to, run your graphics card at by 8 Gen 4, and then you could stuff an M.2 SSD in a Gen 4 link speed directly to the CPU, so alleviating some of those bottlenecking issues going from the CPU to the chipset with the Gen 3 x 4 connection. And that's a pretty good way of running it in my opinion. Sticking with the B550-E gaming, the bottom slot is PCIe Gen 3 x 4. but it actually shares its bandwidth with the two X1 connectors. So if you install something in either of these by 1 connectors, it will drop to reduced bandwidth below X4. Switching over to the B550-F gaming Wi-Fi, you can see that we only get the one CPU-fed Gen 4 slot, and that's probably fine for most people for a board of this caliber. The second full-length slot is actually fed by the chipset, and that's a Gen 3 by 4 link from the chipset. And that slot actually shares bandwidth with the 3 PCIe X1 connectors. So if you install a device in any of those connectors, it will reduce below X4. I'd say that these Gen 3 by 4 connections are probably ideal for installing something like an additional M.2 SSD via an add-in card connector, but because they're routed through the chipset, you are going to have to worry about the bottleneck between the chipset and the CPU communication, and that's a headache you don't really get with X570. In terms of bottom edge connectors, you get the usual set, and this is good to see. Both boards have a pair of internal USB 2 headers, and this is good for card readers and the likes on the front of your case, but also smart AIO coolers and RGB interfaces. You get a couple of 4-pin fan headers on either of the boards on an easy to access location on the bottom edge. And you also get a couple of RGB headers, so one 3-pin and one 4-pin on both of the boards, in addition to some temperature sensor headers. So overall, good configuration down the bottom, and you get a Thunderbolt add-in card header if you do want to add a Thunderbolt card into your system. Showing off its slightly more premium market positioning, the B550E gaming goes one step further and actually adds a 2-digit debug LED along the bottom edge of the motherboard. And this is really good to see because I love these LEDs for troubleshooting. They really are worth their weight in gold when you just don't know what's going on. In terms of audio, both of these Supreme FX based audio systems are derived from the Supreme FX S1220 audio codec. You get Nichicon audio capacitors, and each of the motherboards has dual operational amplifiers. ASUS has a pretty cool feature called AI Mic, and this is something I advise you to go onto the ASUS website and have a greater look at. This basically allows you to install a gaming headset, so just plug it in as normal, but it uses the small load on the CPU, according to ASUS of course, to cancel out any background noise using AI technology, if you like. This is slightly different to NVIDIA's approach where it was using the GPU. ASUS argues that this is a good feature because you're using the CPU, which typically has cycles spare when you're gaming, and you're not using the GPU resources, which is typically really in short supply when you're gaming, so you're not going to see a reduction in frame rates, according to ASUS. Like I said, I'd advise you go over to the ASUS website and have a closer look at this, because this might be quite useful for your feature, especially with everybody now gaming from home and working from home and doing everything from home. In terms of fan headers and RGB headers, if we start off first with the B550F gaming Wi-Fi, you can see you've got a couple of fan headers at the top, so you have 6 in total. 2 at the top allocated for CPU duties. You've got 2 down near the rear I/O panel, and one of these is an AIO pump header, so really good location. And then you've got a couple along the bottom. They're all 4-pin, they all get pretty good control through the UEFI. Then in terms of RGB headers, you get one 4-pin RGB header up top, and then one 4-pin and one addressable down the bottom. Slightly disappointing that we didn't get the second addressable up the top, but I guess that's something that ASUS is doing to cut a little bit of price off this motherboard. And then looking at the B550E gaming, you also get 6 fan headers, however the layout's slightly different. You get 3 up the top, one of which is typically allocated for the AIO pump duty. You get 1 over near the rear I/O, and then 2 along the bottom edge. And in terms of RGB headers, you get 1 4-pin and 1 addressable in the top right, and then 1 4-pin and 1 addressable along the bottom. The fan headers feed directly into ASUS's UEFI control software. You get good fan speed control, you get decent granularity, but you can't really do a true fan speed off mode in certain scenarios, and you get a kind of limited hysteresis control. So good, but not the best. I think gigabytes is still a little bit better, to be perfectly honest. Focusing on the rear I/O ports, let's first look at the B550F gaming Wi-Fi. So you've got a total of 2 USB 2 headers, and these are, or one of them's allocated BIOS flashback duties. You've got 4 5 gigabits per second USB 3 Type A connectors, and these are good for typical peripherals. And then you've got a couple of 10 gigabits per second USB 3.2 Gen 2 connectors, and these run from the B550 chipset, one of which is in Type C form. To be perfectly honest, even at the motherboard of this price point, only 2 10 gigabits per second connectors is a little bit slim, but you could also argue that most people will probably be fine with 2. Looking at the rear USB ports on the B550E gaming, you can see this time we get 4 USB 2 ports, one of which is still allocated for BIOS flashback duties. And then you've got three 10 gigabits per second ports, one of which is in Type-C form, and all of these 10 gigabits per second ports run from a Ryzen 3000 CPU. Now, common connectors between the motherboards are the 2.5 gigabit Intel Ethernet, and this is an Intel i225 controller. So not the Realtek controller we see with some competing solutions, but it's Intel. Whether you prefer that or not is up to you. There are some reported issues with this Intel controller, but they're unlikely to affect most people. You also get DisplayPort and HDMI 2.1, and this is great to see for future APU use where you can run two high-resolution monitors. And then you've got Wi-Fi 6, so an Intel AX200 adapter, high-speed Wi-Fi, and Bluetooth 5.1 capability. The B550-F gaming gets the usual set of audio connectors, but the B550-E gaming actually trades its SPDIF optical output for an audio Type-C header. This is pretty smart to users who now have a Type-C headset because they're becoming more popular, but for old school people like myself who've got a big surround sound setup, it'll be slightly disappointing to see optical being basically sent to the graveyard. And then it's worth noting that neither motherboard gets a rear clear CMOS button. That's fine on the B550-F gaming, but on the more expensive, more premium B550-E gaming, I would have liked to see one, to be perfectly honest. In terms of power delivery solution, if we look first at the B550-F gaming Wi-Fi, it has a 12+2 power stage power delivery solution. The PWM controller is a DigiPlus VRM ASP1106. This controller is likely a rebadged Intersil unit, which is perfectly fine. Intersil's a good brand, and it runs in 4+2 phase mode. As ASUS uses the team design without phase doublers, those 4 control phases for the CPU specifically actually operate 12 power delivery stages. So the way ASUS does this is basically a triple team approach. So each one CPU control phase manages 3 power stages. The power stages themselves are Vishay SIC639 DR MOSFETs, and these are rated for up to 50 amps of continuous current. And then the 2 SoC phases use the same power delivery stages, but they get a phase each of control. And then rounding things out, you've got 5K rated mil standard capacitors. If this sounds familiar, it's probably because it is. So this is basically an identical power delivery solution to the ASUS Tough Gaming X570 Plus motherboard, and we saw that that was a really good motherboard for its price point, with a power delivery solution that was more than adequate for even high performance Ryzen CPUs when overclocked hard. We actually did some more in-depth VRM thermal analysis, so check out that video if you want to see more details. But put simply, despite its relatively limited 4 control phases, this will be a very good power delivery solution because we've proven that with the X570 Tough Gaming Plus. If we now switch our focus to the B550-E gaming power delivery solution, this is actually a 14+2 design, so beefed up from the 12+2 design seen on the F. The PWM controller is a DigiPlus ASP2006, and this is actually a new controller that I haven't seen reported about anyway, so it's very hard to find information about how this controller operates, but based on the process of elimination, I would wager that this is probably an 8 complete phase design operating in 7+1 phase configuration. Probably. If you've got any more information, let us know in the comment section down below. The CPU is powered by 14 DRMOS power stages, and the reason I say stages there is because ASUS again advertises the teamed design. Now, given the process of elimination again, this is probably realistically a 7-phase design for the CPU power delivery with 2 power stages operating per 1 control phase. So a typical double team as opposed to the triple team design that we see with the F. I tried to find some information about the MOSFETs, or the power stages if you prefer, but there is none. So I stripped off the heat sinks, had a look at the part numbers, the model numbers, did some visual analysis. I cannot find any information. I cannot even find which vendor makes the power stages because there are simply no markings on there to indicate which vendor they come from. But if you've got information or comments, let me know and check out the written review in case we are able to update you with more information on how the power stages operate and who makes them. Fundamentally, I'd say that's not a massive concern realistically, provided the motherboard operates fine in our overclocking test and provided the thermals are fine. If we focus on the VRM heatsinks for each of the motherboards, I'm going to give ASUS a, come on guys, let's do better please, here, because these are basically just aesthetic blocks of metal. There's no real effort to make proper heat sinks. They are just literally chunks of metal, not even connected to each other, that just sit on top of the co-packaged power stages, and also they make contact with the inductors. So kudos to ASUS there for adding a thermal strip to make contact with the inductors. There's so little heat that's going to be realistically wasted and pumped out when using a current AM4 processor on these two pretty high-end power delivery solutions. The heat sinks don't really need to be that good, so I guess I'll give ASUS a pass on that one. And in terms of chipset heatsink, each of the motherboards uses a pretty small block of metal, and there's no fan because B550 doesn't have Gen 4 and therefore doesn't justify a fan. Good to see. Anyway, I think that overview of the B550-F gaming Wi-Fi and B550-E gaming is pretty much complete. So let's take a closer look at the performance. Our test system is based around the Ryzen 9 3950X processor. We use this 16-core beast to really stress the power delivery solution on these motherboards. Cooling the processor is a Fractal Celsius plus S28 Prisma 280mm AIO. We've got 2x8GB of DDR4 3200MHz CL14 DDR4 memory from G.Skill. Graphics horsepower comes in the form of a Gigabyte Aorus RTX 2080 Ti Extreme with a custom fan speed curve to minimize thermal throttling. We use a Seasonic Prime TX1000 titanium rated power supply for clean power delivery. Our OS SSD is a WD Black SN750 NVMe drive, and we use a Gigabyte PCIe Gen 4 Aorus 2TB SSD for speed testing and games. We're using the latest retail BIOS version on each of these motherboards, and that's version 0603. That features the AGESA 1001 B550 version. If you want more details on the comparison hardware, our other test system, our test procedures, make sure you head on over to the Kitguru website where you can find more information over there. Let's check out the performance numbers. Starting off with CPU-based performance from the Ryzen 9 3950X, we see both of ASUS's B550 options putting in solid performance numbers. Multi-threaded scoring is comparable or within touching distance of competing B550 and X570 options, and we see reasonable single-threaded scores from Cinebench R20. It must, however, be noted that Gigabyte's competing B550 Aorus Master was consistently equal or faster than ASUS's B550 options in the CPU-focused benchmarks. ASUS's two B550 options take convincing leads versus the Gigabyte competitor in our SiSoft Sandra memory bandwidth test. Latency performance from the ASUS boards also beats Gigabyte's and matches that of the X570 offering. Gigabyte does, however, manage slightly higher ADA memory bandwidth numbers. Aided by their full PCIe x16 connection to the graphics card, unlike the x8 link for Gigabyte's B550 Aorus Master, the ASUS B550 options take comfortable victories in 3D Mark scoring. Both of the ROG Strix options continue to outperform Gigabyte's alternative when looking at gaming frame rates. The performance from the B550 boards is basically identical to that of ASUS's X570 competitor, and that's a clear positive for B550. Full speed M.2 performance is easily obtained from the CPU-connected Gen 4x4 slot. Of course, running any SSD through the chipset-connected M.2 slot will result in lower maximum transfer rates and the introduction of bandwidth headaches through the CPU to chipset link speed. Thermal performance from the aluminium M.2 heatsinks was superior to the alternative design used by Gigabyte. The ASUS boards kept our heavily pushed SSD close to 50 degrees Celsius and showed no signs of allowing the drive to go anywhere near its thermal throttling temperature. We comfortably managed to get a solid 1 gigabytes per second from the chipset-fed USB 3.2 Gen 2 10 gigabits per second ports. SATA performance is as we would expect from the B550 chipset-fed ports. Both motherboards get very good overall ratings from Rightmark Audio Analyzer for their Supreme FX-based solutions. Overclocking through the ASUS UEFI is more difficult than it needs to be, as the load line calibration settings are unclear and feature no explanation or visualization whatsoever. The only way of discovering which LLC setting you require is via a lengthy and wasteful trial and error process. We managed to hit our CPU's 4.25 GHz manual overclock level using 1.3 volts. The B550F gaming Wi-Fi commanded level 4 load line calibration, whereas the B550E gaming took level 3 LLC. ASUS opts to differentiate the way in which its CPU voltage sensor reading is measured. As such, The voltage levels displayed in CPU-Z are highly inaccurate. Instead, we had to trust HWM464 for our voltage readings as there are no onboard monitoring points. According to HWM464, the B550-F gaming Wi-Fi delivered around 1.27 volts under load, and the B550-E gaming delivered around 1.26 volts. This is an accuracy level that we were happy with, especially given the trial and error LLC approach. Both motherboards showed a good uptick in multi-threaded performance from our manual CPU overclock. Of course, Precision Boost Overdrive is still a superior option for a better balance between single-threaded and multi-threaded clock speeds. ASUS's stock voltage levels are clearly well optimized and efficient. We saw no signs of the CPU being misled into feeding more power than it should, which is a good thing. Overclock power draw numbers are also fine and highlight solid VRM performance. Both of ASUS's boards have a power delivery solution that is more than capable of handling even sensibly overclocked 16-core Ryzen chips. In terms of B550E gaming temperatures, sensible voltages help the board run at reasonable levels for the CPU and the VRM. Even with our 16-core chip pushed to 4.25 GHz, the VRM showed no signs of struggling with the heat load. Our manual readings for the PCB temperature near the VRM components showed numbers around 3 degrees Celsius lower than the sensor data, so that is the comparison you should use against the B550 gaming Wi-Fi numbers. We took manual readings for the VRM temperature on the B550-F gaming Wi-Fi, as it, annoyingly, does not feature a temperature sensor reading through HWM464. The VRM temperatures were excellent both at stock and overclock levels. It is incredibly frustrating that ASUS does not display the VRM temperatures in software, as there is clearly nothing negative to hide and only superb performance to display. To summarise then, both of these ROG Strix B550 motherboards offer good performance across the board. We saw the gaming numbers were fine and the compute numbers were competitive against X570. Overclocking performance was absolutely fine with our 16-core Ryzen 9 3950X. The load line calibration settings are a little bit fiddly because ASUS doesn't specifically specify what they do, so I hope this is improved by ASUS in the future. I like the B550 styling. Both of the motherboards look premium. They look like they're quality built. You got obviously the rear I/O cover, integrated I/O shield. You got touches of RGB where relevant. They're good looking. They feel premium. They seem premium, and that's a positive thing when you're spending over £200 on each of the boards. And then the general array of connectors is what I would consider to be pretty good indeed. I'm particularly happy with the Wi-Fi 6 on both of the boards and also the 2.5 gigabit Ethernet. I think that's a really good inclusion. Another point that impressed me, and I was quite surprised by this, was how good the M.2 SSD cooling was. So I was expecting the M.2 SSD to run perfectly fine and nowhere near its thermal throttling point, but I was actually quite surprised by just how much cooler these boards with their aluminium heatsinks and thermal strips were able to run the M.2 SSD versus the Gigabyte alternative. So that's a real positive for ASUS there. And as I've already alluded to, the power delivery solution on both motherboards was perfectly fine during our testing. The B550-F gaming Wi-Fi is pretty much identical to the 12 plus 2 stage solution on the ASUS TUF Gaming X570 Plus, and that's a good thing. We did some extensive VRM testing and found it to be a superb option at the price point. So even though it's only for technical PWM control phases, the fact that you get 12 stages worth of capacity is perfectly fine in my opinion. The temperatures were good, the performance was good. And then the B550-E gaming with its 14 plus 2 stages and its teamed approach also seemed perfectly fine, despite the fact that I couldn't find any details on the vendor or the specific capacity of the DRMOS power stages used. The performance was good, the VRM temperatures were good, and we had no instability concerns, so no problems there. I'm happy to recommend both of these when it comes to the power delivery solution. I will, however, point out that I was particularly disappointed to yet again see ASUS selling a premium motherboard without a VRM temperature sensor. There's nothing to hide. The VRM temperature performance was very good, so I just wish ASUS would include this. It would give enthusiasts using the motherboard, or even novice users trying to learn, peace of mind that they're not overheating. It's really that simple. And then one of the other minor points is that I would have liked to see some onboard buttons on either of the boards, particularly on the B550E gaming, because it's more premium and more enthusiast-based, or B550 enthusiast-based. And I would have liked to see a rear clear CMOS button, particularly on the B550E gaming. So if we break down the boards individually, the B550F gaming Wi-Fi comes in at £209.99 in the UK, and that's £10 more than the non-Wi-Fi version. So in my opinion, that £10 versus the non-Wi-Fi version is well worth it. That's a good deal. However, at £210 in the UK, it has some really tough competition, specifically from X570 offerings at the moment. Where it fares in a more difficult fight is versus the £220, so very slightly more expensive, MSI X570 Tomahawk. Realistically, if you're coming in at the £200 to £230 price point, the MSI X570 Tomahawk is the competitor that you need to take on and that you need to beat. But on balance, I would say the X570 Tomahawk has a better overall set of features. However, there are some specific ASUS points for the B550-F gaming Wi-Fi that will tempt specific users with specific use cases. It's just a very tough battle versus the X570 Tomahawk, it really is. With that said, versus the Gigabyte B550 Aorus Pro AC, I'd say the B550-F gaming Wi-Fi is actually a very good contender. But obviously, when we're talking about money, X570 also falls into the competition bucket. And then the B550-E gaming is £239.99 in the UK. I'd say on balance, this is worth the extra £30 over the B550-F gaming Wi-Fi. I think the improved set of features is justifiable for the extra £30. You're a bit more expensive than the MSI X570 Tomahawk, but I think you have enough features to justify the price increase. So certain areas such as the actually slightly better PCIe flexibility is one of the good points, for example. And then you slightly undercut ASUS's own tough gaming X570 Plus Wi-Fi version and the Gigabyte Aorus Pro. So I think this has got a pretty good position in the AM4 market, provided you're happy with the caveats that B550 brings, but also one of the positives that it brings, which is no chipset fan. I will say though, at $240, this is about on the edge of what I would pay for this motherboard, so I would be pretty happy to recommend it at $240, but if the price stretches any further, especially towards the £280 price point, I think it's going to be a pretty tough sell versus some of the X570 options at $250 plus, and also versus the Gigabyte B550 Aorus Master at about £300, which is a very feature-heavy B550 motherboard. So yeah, overall, two good solutions from ASUS. I'm particularly fond of the B550-E gaming. I think that's a pretty good option. Yes, they're both very expensive, B550, but if you look at their features and their performance in isolation, I'd say the B550-E gaming in particular is a pretty good option at £240 in the UK. So I've been Luke Hill for Kit Guru. Thank you for watching. I hope you enjoyed this review. Let us know what you think in the comment section down below. Are either of these boards the one for you? Would you be swayed by the slightly more premium and bit more expensive B550-E gaming, or does the F offer everything you need, or do you just go for X570 at this price point? Let us know in the comment section down below. If you like this video, give us a like, hit the subscribe button, hit the bell icon, do all that YouTube stuff. Head on over to the Kit Guru website so you can see the written review with more detail and more analysis, and that also helps us out. You can help us out on the Patreon page, and you can also buy a t-shirt from our merch store if you want to help us out even more. Catch you in the next one.